everyone, this is an example of a geometric transformation as a group with the Cayley table. So we have 4 rectangles. I'm going to let the first one be my identity rectangle. So I just wrote A, B, C, D. I went counterclockwise. I'm going to let X be the reflection over the x-axis. So if I draw a little x-axis there, all I did is change my A with my D, and I interchanged my C with my B. All right, and then Y, I did the same thing, except it's a reflection over your Y. Over y-axis. So all I did is change my A's and B's with B going across the Y if this was Y, and I interchanged my C and D, and I let my O be reflection. Let's call this R instead. So this is going to be R equals, this is the rotation 180 degrees about the origin. So we'll call this the origin. So when you rotate it about the origin, basically you're just changing the diagonals. So I interchanged my A and C with my D and B. So those are the geometric transformations. And now we're going to construct a Cayley table. And this is going to be, we're going to let X star Y indicate the transformation Y is performed first, and so Y is performed first, and X, the rotation or the transformation X, is performed second. All right, so that's the definition of this. So when I write this down, I'm going to write I, then X, Y, and R. Do it here. I, X, Y, and R. So for the identity, you get I, X, Y, R, and then X, Y, R. Now X star X gives you back to your original. Y star Y gives you back to your original. And your rotation R star R gives you back to your identity, which is your original. Now X star Y is when you perform Y first. And when you do X star Y, you're going to get R. If you do R star X or X star R, then you're going to get Y here. And then you can kind of change these up here. And the last one's going to be Y, X. Okay, so this is your Cayley table. It's a group, has your identity. It has your inverses. It's closed. No new elements appear. It's also called an abelian group because it's commutative. And you can always see that when you see this diagonal here. So you see this diagonal, and it doesn't matter that this is your identity. When you look to the diagonals of this, they're both x's. To the diagonals of this, they're both y, and for this one, they're both y as well. So this means it's commutative, which means abelian group. And that's it. Thank you. Have a nice day. Bye-bye.